There you go. And make sure you try to stand in front.
I will try to stay in front. Yay. And I'll try to get over here.
All right.
All righty. Yay. Excellent. Very good. Thank you all for coming and joining in person, online. We are here to talk about our formative assessment number 6. Yay. Okay, before I discuss this, I want to do a Lisa. Okay.
It's your show.
I would like to see a thumb up, a thumb down, or a thumb sideways how you felt about formative assessment 6. I see some sideways, I see some good. Okay, so we have a nice mixture of results. And that's actually what we saw, a nice mixture of results. So the goal is to go through to make sure you understand today. I have permission to take, not the whole time, but much of the time as I need to make sure that you're understanding how this works so that you go later on, post-class, you can do this analysis correctly. Okay, so our first question, which of the following equations would yield the correct results for the predicted y outcome for someone with f equals 2, g equals 3, h equals 4, I equals 5? Okay, looking at this, I notice that we have a nice bold statement here to help us out. Predicted y outcome.
I've got to stay by the microphone.
I got to see it right here. This is not the other class.
Nope.
Thank you. Sorry. Predicted y outcome. So with the predicted y outcome, do we or don't we want to include...
Nope. Screen share's not on.
Oh, screen share's not on.
Thank you, Zoomers.
Thank you, Zoomers.
Let me do it.
This one, I think. I think I got the right one.
Screen 2. Yeah, that should be good.
Yep. Cool. Yay. Yes, thank you, Zoomers. So do we or do we not want to include the y-intercept when we are predicting what y should be? I see a yes. Do anybody else agree, disagree? Do we want to include the y-intercept? All kinds of yes. Yay! We want to include that y-intercept, which means that the b sub 0, that we need to include whatever that value happens to be, which is why we can eliminate the first 2 choices. Because if that's 0, 0 times my y-intercept is going to be 0, which means it's going to exclude that when I find my total. Okay, does that make sense? And so then I am boiling down between the next 2 choices. And when I'm looking at those, there's just a very, very subtle difference between b sub 5 and b sub 6. Okay? So if we take a look at b sub 5, it says what we need to do is to multiply whatever that happens to be by the f value and the g value. Important question. What is the operation between f and g? What's that operation? I'll give you choices. Add, subtract, multiply, or divide. What's my operation? Yeah, multiply. Excellent. Which is why what we want to do is multiply the value of f and the value of g to help make our prediction. And so it would be 2 times 3, which is 6. Now, I understand that we haven't looked at the other one, but that was enough information to identify why the green line would be the correct way. But let's go ahead and apply that on the other part and say, well, if this was multiply, this other's also multiply, so we would take 2 times 4, which is why we have 8 with b sub 6. Okay. All righty. Are there any questions about, I know I didn't talk about the first few. If you have questions about why those are the values of 2, 3, 4, and 5, I'm happy to address those as well. But I thought the bigger issue for most people was the 2 times 3 versus 2 plus 3. Are there any questions about our selection at this time?
Doesn't look like.
Okay, very good. All righty, next one. This is where rubber meets the road. You have your choice of a program, Stata or R. What I did, honestly, I went through, Lisa will attest, I took the quiz, okay? I am the most familiar with R. So I actually ignored I ignored
There you go.
the Stata line, and I said, okay, based upon what I know, which one of these fits what I know? Okay, so that's how I would approach it if I were you. If you're trying to learn both and you're more familiar with one than the other, then that's okay. All righty. So we have the same values as before. The only difference is how we come down here and make our choice. So in Stata, the CONT, that is your constant, that's your y-intercept, okay? If it's multiplied by 0, that's not going to include that value as you indicated before. So we are automatically eliminating the first and the third as options, just because of looking at whether or not we include the y-intercept to make our prediction. Then, when we take a look at the difference between the second option and the last option, okay, why are we choosing the last option as opposed to the second option? A couple of good answers to come forth from this. I'm a dad. My kids are 20 and 26. I have lots of patience. My daughter had ADD. I have ADD.
So he's gonna wait for you to talk, is what he's trying to say?
Uh-huh. Why would I choose the bottom one as opposed to the second one?
Make the Zoomers talk too.
Yeah, Zoomers, you must participate too.
There you go.
Why? Okay, ahead.
The multiplication is part of it, like the 8.
Exactly. Because we needed to multiply to get the 8 and the 6 on those last two. Okay. Now that was a very good answer. I like that. The other thing you could have done, and it would have been a good thought as well, is say, hey, I can look to my previous response. And if I look at my previous response, I see that I have to have the 1, 2, 3, 4, 5, 6, and 8. And that has to match my code down below.
Yeah, I deliberately structured these so it was like concept, code, so that you can actually see how you would do it in practice.
And I didn't look, and I think that you said you were adding or did add it, but I'm just going to comment. The one thing I want to make sure that you are aware of, when I'm thinking of it, is that in R, these have to be the order in which you have in your output. Otherwise, it's not going to work the way you expect.
Yeah, it says that in the general instructions.
Okay. I thought that you did, but I can't remember. Very good. Thank you. It is. Okay. Any questions about the second one? Why we make that particular choice? Okay. Next one. Which of the following equations would yield the correct results for the predicted G slope for someone with f equals 2? Okay. I'm looking for the slope. Do I care what y is going to be when I'm done with this? Do I care? No. I don't care what y is going to be. And if I don't care what y is going to be, okay, then do I need b sub 0? No. Okay. Notice that these two have b sub 0. They have the 1. which would be good if we wanted to include that with what I am working with. But I do not. That's why we're boiling down between the second and the bottom. Okay, that's why we're eliminating those two, the first and the third eliminated. Now let's think about our finding of the slope. So if I want to predict G slope, okay, I have 1, 2, 3, 4, 5, 6, 7. I have 7 different terms. Okay, what is the first term that I want to include when I'm trying to find the G slope? Just tell me number 1 through 7. What's the first term that I would want to include 1 through 7 that would have the G slope
Can we
with it?
go beta like 1 through 6 to match the betas?
Oh, how about 0 through 6 or 1 through 6 to match our betas?
So zero's out of the
Yeah,
question.
we'll match our 1 through 6 to match our betas. Which beta do we want to include because we're trying to find the G slope? Yeah, beta 2, exactly, because it has a G in our term, okay? Are there any additional terms in here? And I know there's some great people participating right now, but I'm going to wait for somebody online this time.
It's only fair.
Somebody online, please tell me, if there is another term, and if so, what would be the subscript for beta? If somebody online could tell me what that subscript is.
I'm doing a dribble.
Okay, I'll do worse.
Yeah, they're not gonna play.
Okay. All righty.
Maybe
Since you won't play my game, I'll give you a different game. Okay. What is the third prime number?
What?
I teach math. What's the third prime number? 5. Thank you. Okay. So if we're not gonna do stats, we'll do math. So 5 is the third prime number, and if you take a look, beta sub 5 has a G. Therefore, we will include that when we are trying to find the slope for G. Okay, so I'm looking for 2, I'm looking for 5. If I take a look, do I see any additional G's? No. So let's take a look. I need to have one with 2 and with 5. Okay. There we go. Question. Notice I didn't use my numbers at all. All I needed to do is correctly identify things.
So I'm gonna interrupt. I
Oh, yeah,
promised I
yeah.
wouldn't, but I'm going to. So this one right here, the second option, is by far the most common mistake that folks make. Because they go through here and they're like, f of 2, that means I need to put something where f is, right? But it's like, no, we're predicting the G slope and how f changes it. So f by itself doesn't belong. And that's why it's only the 2 terms, what the G slope is and how f moderates it if you're at 2 instead of 0. So this one, though, this will get you, the second one, and this one.
Okay. All right. Anything else? Okay. By the way, I'm not saying anything about percentages really, because they're all about the same going all the way down through. They're all anywhere from like 70 to like 80%. Got questions
And the
correct.
same for the other class too. They're
Yeah,
almost
yeah.
exactly the same.
Exactly. So.
We're just looking at one.
Next, we go from thought process to code. Thought process to code, okay? What does CONT mean in Stata? What does it stand for?
Containing? Contain?
Close. But no, that is close.
I think it's actually, that's
I
a
thi-
typo. It's supposed to be an S, not a T.
Is it supposed to be an S?
Yeah, it is.
Oh, okay.
So yeah, it'll just yell at you if you run that code.
Oh. No, the state is all wrong.
It's because it's constant, and I was
Yeah.
gonna put like the T
Yeah.
there.
So it's constant. That's our constant, which is our y-intercept.
I'll fix it.
Okay? And so because of that, I'm looking at the first one and the second one and the third one. They all have 0. Is 0 what we want for our constant? If we're in Stata land. If we're trying to find the slope for G. Yeah. That is what we want.
We don't want this.
No, we want 0.
We want 0, yes.
Yeah,
Yes.
we wanted 0 for
Gotcha,
that.
gotcha.
Yep. Nope. Okay. Then, okay, if I am trying to find the slope for G, could we use the same process for choosing which of these 3 we want like we did up here? Could we use that same process? Yep. Okay. So we come down through here. We say, okay, I need my beta sub 2. I need my beta sub 5. And if you take a look down through, okay, we have 2, 1, 2 multiplying. That would be something, but the problem is we're looking for the slope of G, so we don't want F to be involved. Okay. If we look at the second one, okay, this was a lot closer, okay, because we don't want the interaction, but we still don't want the F and the 2 to be in there. And so the last one is what we would like to have because it's only involving the terms with G. Okay, any questions about this one? Okay. Next, which of the following equations would yield the correct results for the predicted F slope? With G equals 3, H equals 4. Same initial question. Do I or do I not want the y-intercept for the predicted outcome? I misread. Predicted slope. Sorry, we're predicting a slope. Do I or do I not want the intercept for predicting a slope? No. Okay? So we need to identify only those terms. We'll look at 1 through 6 that include F. How many terms include F? Yep, we have 3 of them. Exactly. And so we're looking at wanting to include beta sub 1, beta sub 5, and beta sub 6. Those are the terms that have the F there. And if I come down and I start looking at my choices, okay, the first one and the third one say we want to use the intercept. You told me earlier, no, because we're finding slope. So those are gone. So we're down between the second and the fourth. Okay. Now, the F slope of 1, 3, and 4 here, if we take a look, would be okay. Why? We need the F. We need the product of F, which is going to be 1, and G, the product of F, and actually I shouldn't say the product. You actually factor them out. Technically, you did factor them out. Okay. So if I factor them out, it leaves the G and the H, which is the 3 and the 4 for beta sub 5 and beta sub 6.
So can I ask you a question? Mr.
Sure.
Doctor? Could I talk about this as derivatives if I wanted to? Because I've had students try to do that before.
Could you talk about this as derivatives?
Because essentially-
I would say yes,
we're taking the first
Okay.
partial derivative with respect
With-
to
with
f of this
with
function.
respect to f, which is going to turn our constant to 0, our second term to only f, to only beta sub 1, our beta sub 2 would go to 0, beta sub 3 to 0, beta sub 4 to 0. Beta sub 5 would leave g, and the beta sub 5 value, and beta sub 6 and h would be left when you take the derivative for the sixth term, not the intercept, the 6 beta. Yep.
I think that's another way folks can link this to things they've seen in the past.
Yes.
And also in Stata, there's a command called dydx by which you can automate this process more efficiently.
Mm.
And that's what it means.
Okay. All righty. Excellent. Any other questions or thought processes? I'll tell you one thing that I like to do, especially when it gets more complicated. I actually just physically, paper and pencil, I write it down, and then I say, okay, I use my algebra skills of factoring, and I factor out my f in this case, and say, what do I have left? And that helps out a lot. Okay, excellent. So now we're going to go from this to code, and our code is predicting our slope. And I haven't focused on r, so I'm going to look at r this time. Okay, so with r, what does this first value, what's that first value almost always going to, actually, I think it is always going to be that. What does that stand for? Which part of the equation in r is that? Yep, exactly. It's my beta sub 0. And beta sub 0 is always first. It's our y-intercept, which is why in this case, because we're looking at slope, we would want that to be 0. So we have 0 for our r there. We have 0 for r in the bottom. And so we eliminated the first and the third. Then we just need to do a counting exercise. And so we've got 1, 2, okay, so I have my f. My f was going to be a 1 to include that. So I am looking at the second and the fourth. Those are still, I lost my mouse, sorry.
It does run away sometimes.
It does. Okay, so I am down, I got 1 here, and I got 1 there. Then, the difference here between those two is that I got a 3 and a 4 on the bottom, and a 3 and the 4 in the second. If I have 3 and 4 on the bottom, that's including 2 terms that do not have f in them. And that's why we do not want to include those. We're going to 0 them out. Which is why up above you can see our zeros. And I also does not have a value here, so we're assuming that to be 0, held a constant. And then we have our 3 and the 4 for our g and our h, our last 2. F has been factored out, which is why we are left with my mouse hiding over here with 3 and 4, of which they do agree, the second and last one, but it's the middle one because we don't want to include the second and the third beta value. Okay. All righty. Next, we are predicting h slope. Okay, thinking through, looking through. How many terms have the h, since we're working with slope? How many terms? Yeah, 2. Okay. And our 2 terms, looking through, we have our 3, and we have our 6. Okay, there's our h's. Okay. And this is f equal 4. If f is equal to 4, do we want to include beta sub 1? No, we don't want to. Why? because we're looking for which variable's slope. Which variable slope are we looking for? H. And this term does not have h with it. Okay? What would we put in place of our second term? What number do we want there, if anything? What could you put there and not change anything if you wanted? Yep, exactly. 0. You could put 0 there. I know Lisa's condensed it down, but if you wanted to, you could put plus 0. That's not wrong. Okay? That just says I'm not using that term for what I'm working with. All right. And then we'll jump down and say, well, the last term is the only other term that has h with it. So we're looking at the third and the sixth. And if I come down and I take a look at my list, okay, I want to stick with the third one because that's the only one that has betas that are working with h as part of that term. Any questions about our choice? Nothing from Zoomers either. Okay. Let us go into the land of the programming. Okay. Land of the programming. Why am I choosing the third one? You know, I got this. How many zeros does this line have? How many zeros are we working with that line of programming to help us find our slope? How many zeros are we working with? Got 1, 2, 3, 4, 5. Got 5 zeros. Okay? If we take a look at the top, we have 7 terms. 2 of them have h. 7 minus 2 is 5.
Which is prime.
Which is prime, the third one. Okay. And so by that logic, okay, we can take a look. We're pretty close with the first one. Okay, it has 4. What's wrong with the first one? What's included there that we shouldn't be including? What's the first one including that we should not be including on this line right here, or this box? Yeah, exactly. That 0 is the 1. Okay, so that's our issue. That's including the y-intercept as part of our slope prediction. Okay, very good. Any questions about why we made our choice? I'm trying to think about different ways to think about how we can identify if we've set it up. Not if I looked at it, Lisa's looked at it, classmate. No. How can I or you know that you set it up correctly later? Okay. I think there's 2 more.
Yeah, 2 more, but this is my favorite one.
Oh, okay. Which of the following equations would yield the correct results for the predicted I-slope for someone with f equals 2, g equals 3, h equals 4? Okay, for every other one, what was the first, what did I have you count up before? What did I have you count up? Number of terms with whatever. Whether it was f one time, it was h one time. So now we're counting up terms with I. Yay! How many terms have I? 1. Okay. No thought other than how many have I? 1. It's our third option. The first option is very close. Once again, we accidentally included the intercept. The second one said we just plugged in everything we could because everything was listed. That would be good if I was making a prediction for y and I was also told that I equals 1. I'm not told I equals 1. I know it's kind of implied-ish.
Yeah, the
but-
5 and 6 are adding instead of multiplying, so that would still be.
Sorry.
Yeah, that
Yeah.
one would just be way wrong.
That has multiple implications of wrong. Maybe I was thinking about the bottom one's not including, so, Okay. Anywho, but we only want the third one because there's only one term with I. And last one. Okay. How many non-zeros do we want? How many non-zeros do we want? Start counting. 1. Okay, the first one has 1. The second one has all. The third one has all but 1. The last one has all but 2. Okay? So by counting mechanism, we have identified 1, but also and specifically, we have to have the 1 in this location because that is the order in which they are listed in our output. Okay. I know that this is more challenging. Okay? I've experienced this as student, I've experienced it as instructor. Are there questions? No question is, don't call a question dumb. If you ask the question, you are helping somebody else that may not be willing to ask the question. And based off of results, I hope either A, you have a better understanding, or B, have a more knowledge to be able to ask the question that you need to gain that understanding. Are there questions? Zoomers? Zoomers have questions? Roomers have questions? Roomers are questions.
Not spelled the same.
I know. Okay. If you do, feel free to ask me or Lisa or Hillary more privately if you want to during office hours. That's what they're there for. And with that, thank you for your time. And Lisa has about 20-ish minutes.
A little more than that.
Oh,
We got
oh,
3:15.
we got about 40 minutes.
Assuming the clock is right, which it
Yeah.
does appear to be
Yeah, yeah.
reasonably close. So,
Yeah.
there we go. Hi, Zoomers. I'm back. So this formative assessment is more algorithmic. The next one is available, due on a week from now, is more conceptual in terms of like what do these interaction patterns actually mean, because that's what's going to be important in terms of how you describe your findings to other people. But the reason that I'm making you do this is to avoid making errors that I see very commonly in actual results sections of empirical work. Question or comment?
No, me. I'll
You?
say that I have done this error accidentally. I put the wrong thing in the wrong spot and I was unhappy.
Well, so in terms of what stuff means, so we had vocabulary introduced before break, which feels like a million years ago, am I right? Like it's like, am I in this class? Like what's my name? What's going on here? So the predicted I slope, we had vocabulary in describing kinds of slopes that was bivariate marginal, unique marginal, and unique conditional. Those terms ring a bell? Like you've heard them before at least, maybe if you don't remember off the top of your head. So bivariate marginal means there's only 2 variables in the problem, so it's just how they relate to each other bivariately without controlling for anything else. Then we have unique as a descriptor, which means after controlling for. So what is the unique effect of I after controlling for F, G, and H, for instance? And then unique gets divided up into marginal and conditional. And these are answer choices on your last homework 5, which is currently available, in which you get to practice all this stuff. You'll have either marginal or unconditional as a choice, or simple or conditional as an alternative. in this problem in particular, the point that I was trying to drive home is that because there's only one term in this model that dictates what the slope of I is, it has to be unique marginal. It applies to everyone. So if this slope for beta 4 were non-significant, the appropriate conclusion would be, yeah, I doesn't appear to relate to Y, at least not significantly at the sample size and this effect size. And that's fine, that's unambiguous. But where folks get into trouble is if they look at the main effect of F here, the slope for beta 1, and they say, oh, beta 1 is not significant, therefore F doesn't matter. That's wrong. F doesn't matter specifically in people for whom this moderator is 0 and this moderator is 0. But F could matter in other kinds of people who are at different values of those moderators. So the conclusion is not valid to say F doesn't matter, period. It doesn't matter at this point on its moderators according to the interaction. But the idea of these interactions is that beta 5 changes what the slope of F is as a function of G. Beta 6 changes what the slope of F is as a function of H. So that's the pattern that I want to help you avoid, is this sort of unconditional interpretation of slopes that are inherently conditional. And we had walked our way previous to break through examples of the choices for this. Do you remember the 4 kinds of interactions? What these beta 5 and beta 6 type terms can do? Do you remember this? Maybe? Should we do it again? Everyone's staring at me. Yes? Do it again? No.
Yes.
Yes. Okay. So someone needs to vote. That's all. I'd say this is a democracy, but if no one votes, it's more like a school council, like school board election or something. Then like the 10 people who care about that election show up at the school. So, hey, I voted this year. I voted for Coralville's rec center expansion and all the things like that. So that's why I showed up, is I wanted to support them. They do great work, and my son has benefited from their programs tremendously. But these are the 4 kinds of interactions. The interaction takes the slope of its main effect predictor, for instance, beta 2 for X right here, and it either makes it more positive, which is a stronger, more negative, which is also a stronger, and these patterns are known as an over-additive interaction, meaning there's something extra that happens when you're high on both. You can also have a less positive or less negative, which is a weakening or an under-additive interaction, meaning both things don't help as much as you would expect as they would additively. And I used to do activities last year that were not multiple choice questions. They were like essay questions, like free response, because I wanted to get a sense as to how folks were processing this stuff. And I asked the question, what are the 4 kinds of interactions, expecting this to be what folks told me. Oh no, at least a third of the class went straight to ChatGPT and asked what the 4 kinds of interactions were, and I got all kinds of different answers. And this amused me so much that I wanted to put them together. I reorganized them just to give you a sense as to how other people might talk about these things. As it turns out, ChatGPT doesn't get the answer right a lot of the time. But at other times, it turns into word salad. So you can have a synergistic interaction at which the effect of the focal variable becomes stronger as the moderator increases. That's stronger, right? That's over-additive. You can have an enhancing interaction where there's stronger effects at higher levels of the moderator. What I just said. A strengthening interaction where the effect of the predictor becomes stronger. So all these different terms mean the exact same thing. And non-crossover, a lot more words here, but the same general idea. Then we get into the other category, the weakening. An antagonistic interaction. That sounds like mean, almost, like they're doing something to you. The effect of the focal variable becomes weaker as the moderator increases. Opposing effects. When they work against each other, that's your key. If the signs are opposite, you're in a weakening pattern. If the signs are the same, you're in a strengthening pattern. Buffering, weaker effects at higher levels of the moderator. Weakening, there's that. Reversing. And the only other one that I accepted as not a synonym is crossover, which is where you get a pattern with specifically a categorical moderator, where the slope is positive in one category and negative in another. And so they make this pattern. I don't think I've ever seen one of those in real life. Like, that's just a thing you see in textbooks or experiments where they've controlled everything to create this sort of weirdness. So you can use whatever fancy synonyms you want, so long as you can identify the pattern. What I also see folks do in results section that is unhelpful is to say something like, the interaction was significant, so we have moderation. And then they like make a picture and that's the end of the sentence. It's like, no, what kind do you have? Is it making this effect stronger? Is it making it weaker? Is it positive to begin with and becomes less positive? That's different than something that was already negative and becomes more negative. So just keep that in mind, that in terms of like, this is algorithmic stuff that's very dry, and I understand that, but it's the bare bones to actually trying to communicate your results to an audience that should hear. So you get a little more practice on that next time. And homework 5 to practice with a story prompt. All right, how are we feeling with this, folks? Feeling like maybe we can do this? Has anyone started homework 5? You have? How's it going? It's good?
Excellent.
Yes. Do you want to hear the story of where homework 5 came from? I can tell you the story, but only if you let me use a curse word. The story is not funny without it. Okay. So homework 5 is all about cutthroat Scrabble and how verbal skills you would expect would enhance your Scrabble ability. Surprisingly, spatial skills can enhance your Scrabble ability as you figure out where to put the words. And there may be an interaction that depends on how effective your opponent is in taking the triple letter squares and things like that. So where this story came from was back in, I want to say 2010, 2011-ish, the game Words with Friends came out on our cell phones. I'm still playing. Okay, I play my husband, who is the star of this story, Jonathan Templin, the E.F. Lindquist chair of our program. And I play my mom, I play my aunt, trying to help them, maintain their cognitive capacities. So I never played Scrabble as a kid, and honestly, I'm pretty terrible at it. My problem was that I couldn't find where to put the things, and so I'd end up hoarding the letters and never spending them and not getting enough points. And so Jonathan and I, when this game first came out, we just like hang around the house and playing it. And one time, I got the chance to go to St. Pete's Beach in Florida in February. I was the coordinating officer for Professional Society, and they had a mid-year executive meeting where they decided to have it at the beach because that's where the annual meeting was going to be. And I was living in Nebraska at the time. I'm like, hell yes, I'm going to Florida on someone else's budget in February. I'm here for this. I asked Jonathan if he wanted to go. Sure, he wants to go. So we went over, we arrived on a Saturday. It was like the meeting was all day Sunday, and we were going to get to stay like 1 or 2 more days. And I'm trapped inside the hotel all day in an overly air-conditioned room being talked at by older people in this meeting all day. And he's on the beach instead because he's not part of this group. So he comes back to the room around 4:30 after I get done, a little sunburnt, carrying what looks to be like a big gulp. And it is a rum runner. I'm not sure if you're familiar with these, but it's a drink about yay big and about 75% of it's alcohol, give or take. So he's like, hey, baby, how's your day? And I'm like, how many of those have you had? Oh, I don't know, like 3 or 4 maybe? So he had a great day, and I'm kind of jealous. So we're hanging out, trying to figure out what we want to do for dinner, and I'm laying on one of the hotel beds with my phone, playing the game, and he's laying on a different one. And he keeps like playing and then like passing out in between turns. And then the phone dings, ding, playing, and then passing out. And at this point, I'm irritated because he's beating me by like 100 points, okay? I'm like, how are you beating me and literally passing out between turns? He's like, I'm fucking gifted. Back to sleep. And what's so infuriating is that he is, okay? He is. He has 3 patents. Like, he's like a super genius. And he beats me at almost everything, Words with Friends included. So what I learned from that is that verbal ability, which I would like to think I have, can work against you if you have very poor spatial ability, which I definitely do. I get lost in closets. So that's the story of where the homework came from. That may help you in understanding some of the interaction terms and how opponent matches with that. So any questions on that? All of my homeworks are based on real stories, by the way. Yes?
Do you actually play multiple games with your husband that actually beat you all the time, or do you choose not to play multiple times?
We still play, and he beats me at about a type 1 error rate. Like, or I beat him, excuse me. About 1 in 20, I'll beat him. Give or take. Yeah.
And you're still willing to engage? Wow.
I am, because I'm trying to keep my cognitive capacity, intact.
Fair enough.
So, it's fun. But anywho, that's the story of the Scrabble. I had promised that you would be able to use the first two models to complete that homework, and we went over part of them last time. Would you like to see this again? Re-go over or review? Review? Okay, Zoomers, how are we feeling? Zoomers are very quiet today. Yeah, I'm also a parent. I'll wait. Okay, they're thumb upping. They're like, no, we're here. We just don't want to answer your questions. That's fine. All right, reviewing then. So this data set is fake, but based on real data. Older adults were predicting cognition as a quantitative outcome from quantitative age in years. Grip strength, which is a proxy for physical fitness, at 9 pounds per square inch is our centering point. A binary variable for gender, where men are the 0, women are the 1, and a dementia diagnosis category, never going to have it, are going to have it eventually, or currently already have it. So we walked through creating variables, for instance, dem group, for instance, we had to make binary contrasts for that. That way we're not treating it as if it were a number. There are ways to make the software do that for you, by the way, and I've deliberately hid them from you. But in R, if you designate a categorical predictor as a factor variable, it will do the dummy coding like this for you. The same is true in Stata. If you write I dot instead of your predictor, instead of C dot, it will do this for you. But you lose control as to what the binary contrasts mean, that there's only one choice, basically. So we had a main effects model. So in this analysis, each of our predictors is in without any interaction terms. So that means if I were to ask you about any of these slopes in here, are these marginal or conditional? Yeah, not a trick. Yeah, these are all marginal, meaning that without any interaction terms, beta 1 is the change in cognition per year of age, period, for everybody. Likewise, beta 2 is the change in cognition for a 1-unit difference in grip, period. These two work together to describe the effects of dementia group, where future is the difference for beta 4, current is the difference for beta 5, both relative to none, but they are also marginal effects. Are these all unique as well? They have to be. Bivariate means only two things in the problem at the same time. So we walked through, I think, the results of this. So for every year older, what happens to your cognition? Up or down? Let's make this simple. Down. Yeah, down by 0.4. For every unit stronger, up by 0.6. What about women relative to men? Yeah, they're lower because they're the 1. So a negative slope for a binary predictor means the 1 group is lower. And likewise, folks who do not have dementia, the none group, are a lot higher. The alternative groups are a lot lower. So we can talk about how effective the model is as a whole by paying attention to the R square. So about 28% of the variance was explained by these slopes. And the model does significantly predict cognition with this F and this p-value at a traditional level of alpha. One extra thing that I asked for is the difference between the alternative groups. I can get that with a calculator simply by subtracting one of these from the other. So a difference of about 11 or so. I can ask for that within R and Stata using GLHT, the contrast that we just described, and here's the 11. So now I know then that the other groups are significantly different as well. Okay, and then for homework 5, this analysis should be very close to the type of structure that you would need for your interaction term. So we are adding first interactions with age and gender and grip and gender. So this would answer a research question about whether there are gender differences and the effects of these predictors. So in other words, age is related to lower cognition. Is that true to the same extent in men as it is in women? The difference in the slope of age for women is going to be given by beta 6. Likewise, is the effect of grip different for women than men? How different it is for women is going to be given by this beta 7 term. So the interactions always tell you about differences between slopes. They do not tell you what the slope is going to be in the alternative group. That's an easy thing to get confused. And it looks like I have my code from last time here that I was playing with edits. Do you remember what the multiple hashtags do? Say to users? It fits the lower order terms that are implied by that interaction. So if you have two hashtags, that means fit both the main effects and the two-way interaction. I don't have to have that because I've already listed out everything here.
Also,
Question?
No, just like, I don't know if you re-upload, but I think that on the, if you go up a little bit, I think you had, or you had like 3 connected, I don't think you have 3 connected in your model.
Yeah, that's right. I was trying to demonstrate
Well,
what it would
right,
look like.
right.
Thank
No,
you.
I knew that what you were trying to demonstrate. But
Yep,
if
you're
you-
right.
If you,
Future Lisa is very appreciative that we just fixed this, because I'll look at this like 3 years from now and be like, I don't get it. What was I doing? I was demonstrating how to make a 3-way interaction. That's what I was doing. Okay. So look, our model is significant. Does that mean these interactions helped? Got 1 no vote. My statement is, hey, look, my model is significant. Does that mean my 2 new interactions helped it? Can I know that yet? Here's your clue. 7 slopes. So F is a joint test of all 7 slopes in the model. And it is a per slope metric, to where you're essentially saying per slope, how much better did your slopes do than what would have happened by chance, essentially. The average contribution if there was no effect. What we want is a direct test of these 2 terms and whether they have improved the model R-square. So we got to ask for that. If you're in Stata, that can be a test statement, or you can use nestreg. If you're in R, it's going to be GLHT as well. But it looks like, just based on the individual p-values, that these terms are not helping the model. Let me zoom in so we can look at the signs. Irrespective of significance, because I know you can stare at p-values all day long and make that decision, I want you to know what to do with the pattern. This is the slope of age, right? 0.23. It's not significant. So should I write down, therefore, age doesn't matter? Nope. This is a conditional slope. Who is this the age slope for, given the interaction terms in the model? Yep, the men. So age doesn't matter in men is what this is saying. What happens to the age slope in women? Which pattern is this? Yeah, the signs match. So this is a strengthening, this is a more. And since the signs are negative, this is more negative. In other words, the age slope becomes significantly stronger, more negative, by 0.29, or non-significantly, 0.29 in women. So this is what it is in men. This is how different it is in women. To get to what it would be in women, we would add these 2 things together. And we don't know from this output if age would have a significant slope in women. But we can ask for it. Yes?
So both the age and the interaction are non-significant according to p-value.
According to this, yes.
Now, is it a potential that one of them is significant and the other is not? For example, could age 85 be non-significant but the interaction is?
Yes. Yeah, you could have any combination of significance of a conditional main effect and the interaction term. So one thing to keep in mind is that this result is not comparable to the previous one. So let me see what the age slope was before. It was negative 0.4 and it was significant. Now, the age slope is negative 0.23 and non-significant. It is based on less power, because now this is specific to the men in the sample, and women outnumber them. So it's a different answer to a different question. Does age matter in men? Not according to this. Does age matter in women? We don't know yet. But we can ask for that. So down here then, I have the logic by which we can ask for the simple slopes of age and grip for either sex. So we start by identifying everything in the equation that has the term we care about, in this case it's age. We factor out the variable the slope is for, stick that behind, and what's left are the ingredients. So at a minimum, we need the age slope to form a predicted age slope, and then we need to adjust it based on which gender we're predicting it for. So if we're predicting it for men, this goes away, turns into a 0. If we're predicting it for women, we would put a 1 in here, in which case we would need to add together these two coefficients. So that's what is happening in this LinCom right here. I am adding together the main effect slope for age, along with the interaction of age and gender, and that result is minus 5.2, and that is significant. So it looks like age does matter in women, age does not matter in men. However, those slopes are not different, according to the interaction term. And that sounds contradictory, but it's not. A slope can be significant in one category and not the other, and yet the difference between the slopes also not be significantly different. In general, a rule of thumb is that it takes twice as much power to detect an interaction as it does to detect its constituent main effects. Interactions are hard to find. That's just reality. So the way I would report this is trying to put it all together. Age doesn't matter in men. The age slope does not differ in women significantly. However, the age slope is significant in women. All of those things are true. Same deal with grip. Which pattern is this? Grip in men is a slope of 0.7. What happens to it in women? Negative interaction. Yeah, it's weaker. This is a less negative. The signs are opposite.
Less positive.
Yep, thank you. Where's my Mountain Dew when I need it? Water is not working for me today. Gotta tell you. Yes, grip strength has a positive slope. If you want to get smarter, go to the gym. Oh wait, it's backwards. In women, grip strength slope is less positive. So being strong is less helpful in women than men. That's how I would say that. Helpful is a way to convey the effect of a positive slope on an outcome where it's a good thing to have a higher score, such as cognition. And then you can compute the difference in R-square across models. I did that here using saved estimation results. NestReg will also do that for you directly within Stata. And here's some pictures. So if you have an interaction, pictures are really essential. And in this case, I'm showing the effect of age on the x-axis for different genders as the moderators. And in this picture, I'm doing the same for grip strength. In R, in order to test whether the two new interaction terms improve the model prediction, the analog to NestReg or test is a function that I wrote that hacks a couple other functions and prints the output a little more nicely. It wants to know what your base model is, what the augmented or fuller model is. So I'm feeding in the summaries that I've saved of these two things. And it is then saying, for adding those two slopes, here's your f-test of their contribution. It's not significant, and here's the change in the R-score that it created. So I got all the information coming out of just one function here. To get the simple slopes, this is where we do the filling in of the numbers. Why is that one in different font? I don't know, that's gonna bug me too. I don't know. No, it's in equation font for some reason. Was I messing around with that?
Oh, that is bizarre.
It is.
You typed it with a 1 underlined at point, or is that underlined 1?
There you go, it's fixed. So in this case, I have a 1 in both of these spots because that's for the age slope. And then I have a 1 here because it turns on for women as the moderator through the interaction term. Likewise down here, I have a 1 for the grip strength slope, and then a 1 for the grip strength interaction term to turn the grip strength slope on for women. And the results are the same as what we got in Stata, just compiled into one little table here. And then I made some pictures. So this process of making pictures is not plotting the raw data. I've had students try to do that, it doesn't work. What you have to do to show the pattern of an interaction is control everything else that you don't want to show. Meaning hold it constant at something. It doesn't really matter what the something is, because if they're not part of the interaction, different value choices for what to hold constant at would result in the y-axis shifting, but not the pattern of the line shifting. So in this case, what I'm asking it to do, this is a function called prediction from a package with the same name, is generate predicted values for grip strength 9 from -3 up to 3 in increments of 6. So just those two numbers. And why do you think I picked these values?
Standard deviation.
Yeah, they're roughly plus or minus 1 standard deviation as what examples of low and high would be. And so what I had wanted to plot was grip strength of 6 versus grip strength of 12. So why does it have to be -3 and 3 to get that right?
Because it's centered at 9.
Because you can't forget the centering, okay? These are common things that folks do when they're first learning this. It's really easy to forget that part. But it has to be relative to what the variable is that's in the analysis. So if I want 6 and 12 and 0 is 9, then this is what I got to put in. Likewise, age is centered at 85. If I want predictions for an 80-year-old and a 90-year-old, then this is what I got to put in. And then I am asking for it to also generate those same predictions, holding gender at 0 and then holding it at 1. And then listing the other categorical predictors that are not part of the story as 0 specifically, so this plot would be for someone from the none group. If you don't do that, if you try to aggregate over your data and make plots with that, you're not holding constant the other predictors, and it's not going to look right. So what I always would recommend is figure out like what are good values for low and high based on the distribution of your data, and then sort of make it like a blocked combination, like show all possible combinations. The exception to that would be if you get into a corner that doesn't exist, right? So in this case, I'm showing weak people and strong people and young people and old people. There's probably not a lot of 90-year-olds with 12 pounds of grip strength. Like it would be unusual to be super old and super strong. So it could generate error messages saying, hey, you don't even have this person in your sample. What are you doing? It will do that to you. That means you might want to change what you're plotting to make it a little bit more reasonable for what the scale is. But I have code online for making pictures, and these are really ugly, but I'm very proud of them because it worked after a long time. I often make pictures in Excel, and it's not the most efficient process, but the reason that I do it is twofold. One is what I used to call pedagogy, but which I recently learned is andogogy. Is that a word? Any educators in here? Androgogy. It means pedagogy for grown-ups, because like ped is kid, and I'm like, oh, that makes sense. One is pedagogy. The other is practicality. As a methodologist, I'm very, very frequently working with people where I do the results or I help students do the results, and the PI is the one who's leading the manuscript. Well, the PIs want plots, but the PIs sometimes change their mind about what their variable is called or what values they want to plot or what the axis should be labeled. And if I don't want to redo the code 18 times to make whatever changes are deemed necessary, I will hand them an Excel file that they can edit directly and do whatever they want to. And that makes my life easier. So that's why I do things in Excel. But if you have a program and you and all your collaborators use the same program, that would be much more optimal to do it in code so that it's more reproducible and less prone to human error. Yeah?
If time permits, would you mind showing them a couple of the plots in my presentation I gave last in R so they can see how it can be done?
Yeah.
Let me just show the result, not the,
Like just examples of what pretty pictures look like?
not necessarily pretty pictures, but
Sure.
that you can do things in R for those that are using R.
Oh yeah. No, everyone tells me R is wonderful for plotting, right? But it is as long as you're willing to invest 100 hours to figure out how to make one stupid plot, and I'm just unwilling to do that most of the time.
Yes.
But no, Michael has gotten better at this than me.
Yeah.
So isn't that pretty? It's a nice happy little scatter plot here. I like the color overlay. Here's another happy little scatter plot. Oh, we got
Box
some
plots.
box plots. What the hell happened with section 10, dude?
They suck.
So this is
No,
his.
okay, technical term.
Yeah, this is his presentation.
They were non-high achievers.
Yes, so he's studying how grades are, how much they differ across sections of a course and
Based upon a quiz
semesters.
score.
And it's the same thing that's happening, so it should be standardized, but this group, whatever reason, it didn't go well. So these are examples of prettier pictures that you can make. And then you
The
can
red
do,
was not a picture I made in R.
yeah, no, then line plots and things like this, yeah. So I think it is if you're gonna be an R user or a Stata user, it's a good skill to invest time to figure out that particular program.
If you want to, if you see me and you want to know how to do that, you can contact me.
Yeah, and
Or
we can
do
send
like I did,
examples.
it's called Google. Google the command and then modify.
that is one thing that ChatGPT can help with, is like starting your R code.
Right.
Also Copilot. Have you played with this before in R? Oh, it's kind of awesome.
Yeah.
It's not good at first, but after you start to use it, it anticipates your code and your comment style and everything. So like, I'll make like one thing, and if I need to make 3 things like it, it'll be like, did you mean this?
Mhm.
Yes, I did, thank you. And it's wonderful. Other times it's like, did you mean this? And it's like, not even close, but thanks for playing. So it doesn't help you if you don't know what you're doing yet, but if you do and it's tedious and repetitive, it does help for those situations. So you can activate Copilot inside R Studio, and I would highly recommend that. So anywho, this is all the results that I would say about that model. Since the interactions were not significant, I would report that they did not help and move along. And where we will go next, I have noted, is not needed for homework 5, but is potentially needed in life. Because how to understand a quantitative by quantitative interaction is something that folks don't often get taught. It's almost always in the context of groups, which is easier. So I do want to show you this and some cool tricks to making these more understandable. But that is not a today problem. That is a Thursday problem. All right, questions or comments as we wrap up for the day? Are you gonna all go play phone Scrabble now with your loved ones?
They'll help with homework 5.
It might, actually. Maybe it's sort of like doing homework preparation activities, right? Just to play Scrabble with your friends. All right, well, if you need help, please don't hesitate to reach out. We're happy to do so. Hope to see everybody on Thursday then. Bye for now.